Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over the differences between molecular mass, formula mass, and molar mass. So let's get into this. So first let's talk about molecular mass. Molecular mass is the sum of the atomic masses of each atom in a molecule. So hence the word molecular mass. So why is this important? Keep in mind that this applies to molecules, or this is applying to covalent substances, substances that are made up of nonmetals. So we call that a molecule. So a molecule is basically a unit of something that you can have a distinct, or how should I say, a distinct formula for. For example, water is H2O. It has two hydrogen atoms bonded to an oxygen atom. You don't get that with ionic compounds. So ionic compounds, which I'll get into in a moment, are ions bonded together, and they form a crystal structure where you can't really point to a particular unit in the structure and say, aha, this is the molecule of sodium chloride or something like that. But for something like water, they do have discrete particles that you can pull out that has a particular formula to it. So that's what we refer to as a molecule. And then when you find the molecular mass, you're basically looking at all the atoms in the molecule, you're adding up all of the atomic masses, and then the total is the mass of your molecule, or the molecular mass. So using water as an example, the molecular mass of water, since water has a formula of H2O, it has two hydrogens, one oxygen. Therefore, you're going to add up the two hydrogens. So you're going to multiply 2 by the atomic mass of hydrogen. So here we have the atomic mass of hydrogen, 1.00794, or if you want to round it to 1.008, that's fine too. But the idea is that you're adding two of these together because you have two hydrogens, so 2 times 1.00794. And this is the unit AMU, which is for really small particles, atomic mass unit. So that's the unit that we're using here for individual atoms and molecules and formula units. And so we're going to multiply 2 times the atomic mass of hydrogen because we have two hydrogen. And then we're going to add to that the atomic mass of oxygen, which is 15.9994. Since we only have one oxygen, we're just going to add that once. And so the total becomes 18.0153 AMUs. So that's the molecular mass of water. So this would be the mass of one molecule of water in the unit of atomic mass units. Okay, so that's molecular mass. What about formula mass? So formula mass is very similar to molecular mass. However, this is a much more general term, and so it applies to a wider range of substances. So formula mass is going to be the sum of the atomic masses of each atom in a formula unit. Now, what is a formula unit? That is normally used to refer to ionic substances. And as I was saying, we want to use a more general term for ionic substances because ionic substances don't form molecules. So we really can't call them, we can't use the term molecular mass for something that doesn't have molecules. So, but it does have a formula. So, for example, if we use NaCl, because NaCl is a crystal structure, it's made up of ions, you have to understand that each positive ion is surrounded by negative ions, and each negative ion is surrounded by positive ions. So if I draw kind of a picture here, right? So if I have a plus, a minus, a plus, a minus, a plus, a minus, and this would be a minus, a plus, minus, plus, minus, plus, and then this would be a plus, a minus, plus, minus, plus, minus. And so what you can see here is, so this plus, hey, is surrounded by 4 minuses, top, bottom, right, left. But you also have 1 in front, 1 in back. So you got 6 negatives surrounding a positive. And the same thing goes for the negative. The negative is surrounded by 6 positives. So what is the formula of an ionic substance? Well, it's the smallest whole number ratio of positive ions to negative ions. How many negative and positive ions do you need to balance the charge? Well, if it's NaCl, you have a plus charge on the sodium and a negative charge on the chloride ion. So it's a 1-to-1, so we only need 1 each to balance the charge. So the formula for an ionic substance, if this is our, let me do one more, so negative, positive, negative, positive, negative, positive. So if this is my NaCl structure, this is my crystal of sodium chloride, then I could choose, let me use a different marker here. So I could choose this as the unit, or I could choose this as the unit, right? Or I could choose, let's see, I could choose this as the unit, right? So out of all of these, I have a few formulas that I could use, right? So if I choose this one, then I get 1 each, that's NaCl. If I choose this one, that means I have 2 positive, 2 negative, so I have 2 each. So the formula would be Na2Cl2. If I choose this one, I have 5, well, I would have, in this case, 5 each. Actually, I'd have 4, 4, and 5. That's not a good one. Let me choose a different one. I thought that was 5 and 5, but I wasn't being careful. Oops. So here, what's another one I could choose? Let's see. I could choose this longer one here, this one here. So that works. So if I choose this one, I have 3 positive, 3 negative. So that would be Na3Cl3. And so which formula is the correct formula? They're all neutral because all ionic compounds have to balance charge. So Na and Cl, that's neutral, +1, -1. Here I have 2 positives, 2 negatives, that's neutral. I have 3 positives, 3 negatives, that's neutral, and so on. I could have Na4Cl4, Na500Cl500, right? So which formula is the molecule, right? Right. So molecule is supposed to be a discrete unit of your substance, but we can't point to anything in here as that's our discrete unit, right? Because we have several different possibilities. We have an infinite number of possibilities here, it seems. So in order to get the formula for an ionic compound, the tradition is we just take the simplest whole number ratio version. Since this is a 1-to-1 ratio, all of these are 1-to-1 ratio. 1-to-1 is the simplest, so we take NaCl as the formula for sodium chloride, and we call that the formula unit. And so the mass of this substance, NaCl, for the mass of this formula, we call the formula mass. So here we have the formula mass of NaCl. We're just going to add up the atoms that make up the formula unit of the sodium chloride, of this ionic compound. So we take NaCl, so the mass of NaCl We add to that the mass of chlorine, and we get the mass of NaCl in, again, atomic mass units. So that's the distinction between a molecular mass and a formula mass. Now, let me say straight off the bat that you're probably wondering, well, H2O has a formula, so why can't we call this the formula mass of H2O? Well, you can. That's because a formula is a more general term. It applies to molecules as well as to ionic formulas as well. So you can call this the formula mass. The molecular mass of H2O is the same as its formula mass, right? You could, the mass of single atoms, you could refer to that as the formula mass because that has a formula. So it's a much more general term than molecular mass. Molecular mass only applies to molecules, which are covalent substances, not ionic, not metallic, just nonmetals. Okay, so that's molecular mass and formula mass. Now, what about molar mass? Well, molar mass is basically the same as formula mass or molecular mass, but in grams. So here, the definition of molar mass is that it's the mass in grams of 1 mole. And again, remember, a mole is 6.022 times 10 to the 23rd particles. And again, a particle could be an atom, could be a formula unit, could be an ion, could be a molecule, whatever. Whatever the particle is, 1 mole is that number of that particle, right? So molar mass is the mass in grams of 1 mole, 6.022 times 10 to the 23rd particles, of a substance. This will be the same as the molecular mass or the formula mass. So what does that mean? So if we look at water here, we calculated that the molecular mass of water is 18.0153 AMUs, atomic mass units. Well, what is the molar mass? It's the exact same number, except it's now in grams. So the molar mass of water is going to be 18.0153 grams for every 1 mole per mole. So if I have 1 mole of water molecules, I'm going to have 18.0153 grams of water molecules, 1 mole. Same thing for the molar mass of NaCl. We saw here that the formula mass of NaCl is 58.4425. So the molar mass is that exact same number, except now it's in grams, 58.4425 grams per 1 mole. So 1 mole of sodium chloride is equal to 58.4425 grams. 1 mole of water is equal to 18.0153 grams. So the only difference between, say, a molecular mass or a formula mass and the molar mass is the unit. Here, it's atomic mass units, and this is per 1 molecule or per 1 formula unit. This is per mole. This is grams per mole. Same numbers, different units. And let me just finish by saying that here, because we have molar mass, we have a relationship between grams and moles. You can use this as a conversion factor. So remember, molar mass can be used as a conversion factor to help you convert between grams and moles. So if I set this up like a fraction or a ratio, if you will, it would look like this. I'd have 18.0153 grams of water over 1 mole of water, right? Or I could have 58.4425 grams of NaCl over 1 mole of NaCl. So I can use this as conversion factor. And remember, the conversion factor can be flipped depending on if you want to go from grams to moles or from moles to grams. So remember this. This is very useful. So that's it for this video. I hope this was helpful in helping you understand the difference between molecular mass, formula mass, and molar mass. If it did, if you learned something from this video, and if you enjoyed this video, then please like the video. Hit that like button and also share with your friends. Make sure that you subscribe to my channel. Tell your friends to subscribe to my channel. And then also hit that notification bell. When you do, make sure you click all so that way you can be notified by all the videos I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a topic you want me to cover, or if you have a particular question that you're struggling with, or a problem you want me to help you with, please put it down below, and I would love to do that for you. Thanks for joining me, and have a great day.